Here is a very difficult log question, but it sums up the kind of skills you need across the whole of the topic. So when you look at this question, the first thing you should think is, I'm going to use the laws of logs. And the second thing you should think is, there's no way I want mixed bases. Never. So we're going to use the change of base formula because that is our first consideration. So let's do that on here. And that's a very straightforward thing to do. We just apply the formula. Now let's deal with this top here. What is log to the base 3 of 27? There's two ways to do this. One is just simply by understanding what is a logarithm. Log to the base 3 of 27, the answer to what that is equal to is the answer to this question. What power of this base gives us the number 27? It's obviously 3. Or you can just use the laws of logs. Obviously, you recognize 27, it's 3 cubed. Then I can bring the power down with the most important third law of logs. And then you should know that log to the base 3 of 3 is 1, because 3 to the 1 is 3. So this whole thing is 3. So what are you looking at here? And get an answer in your head. What is this type of equation? How would you describe it? Yes, you're correct. It is a hidden quadratic. And that means a quadratic that doesn't immediately look like one, but with a little bit of manipulation, it is one. And so what I'm going to do is multiply everything through by log to the base 3 of x. And whenever you're faced with algebra, you should be saying to yourself, get rid of brackets, get rid of fractions. We want to simplify things. We've got a fraction here. So let's get rid of it. And I'm going to do that by multiplying everything by log to the base 3 of x. So this is a really important skill coming up. So many students, when they multiply log to the base 3 of x by itself, somehow turn it into some kind of law of logs. It's not. It's log to the base 3 of x times itself. So it's log to the base 3 of x squared. This one just turns into 3. That was the reason we did it, to get rid of fractions. And obviously we get 2 log to the base 3 of x here. What should you do next? You're good at quadratics now. What is the next move? Yes, you write it in the correct format for a quadratic. Now, sometimes when it's a really nasty quadratic, I like to just replace the log to the base 3 of x with a k. But this one is not so nasty, so maybe I won't do that. I'll just factorize it. So it is k squared plus 2k minus 3. Always double check your factorizations. I've got the squared. I've got 3 times minus 1. I've got a plus 3 log x and a minus log x. Perfect. So if you have a factorized expression equaling to 0, we can say one of the two must be 0. Fine. Is this one okay? Is this negative okay? Yes, it is, because you cannot have a negative inside a log, but that doesn't mean a logarithm can't equal a negative. Let's just now rewrite this logarithm as an index equation. And so I've rewritten it. I've got the same base in this equation here and this equation here, which is 3. So 3 to the minus 3 is x, and this one, same base, 3. 3 to the 1 is equal to x. And then it's nice if you formally write your answer down. Lastly, with a logarithm question, I'm just going to quickly check both of these are safely valid. In other words, in the language we just used in today's lesson, are they in the domain? Quick check at the original question. Am I allowed to put 1/27th in here? Yeah, you can have fractional bases. We don't actually study it, but it does work. And the other one was 3. There's no problems. There's no negatives. Everything is fine. Tough question, but lots of skills.